This film looks at the effect of caffeine on heart rate of the water flea Daphnia. You can see we're going to use 4 caffeine solutions. We'll see what they are later. The Daphnia are handled in a piece of equipment called a solid watch glass. The cotton wool is in there in order to trap the Daphnia so they don't swim about. The cotton wool is moistened with some of the pond water that the Daphnia are living in. Best use filtered pond water. And then a Daphnia is transferred using a wide-mouthed pipette. You can see it there in the centre of the cotton wool. The whole thing is then placed on the stage of a simple compound microscope with low power lens in place. You don't need any higher power than this. The heart of the Daphnia is one of many things that are moving in the animal when you see it through the microscope. You see it labelled there, it's kind of up between the Daphnia's shoulder blades, if it had shoulder blades. The other things that are moving are feeding legs, swimming legs, and even the eye, which is the black structure towards the top of the animal. You can see the swimming legs there moving, feeding legs are in the front. The heart is beating away at the back. You can even see movements going on in the gut in front of it. The gut's kind of greenish due to the algae that are in there that the Daphnia has been feeding on. All the strands that you can see in this microscope shot are cotton wool fibres. And you see they quite effectively hold the Daphnia still without doing it any harm. Here we can see the heart more closely. The gut to the right with the green algae in it, and the heart beating away, and you can even see the blood vessel coming out at the bottom of the heart. So it's important to identify where the heart is. It's quite common for students to count the wrong thing. Now of course it's quite difficult to count these heartbeats. As you can see here, it's going very, very quickly. So how to do it? Here we've got clips of the Daphnia's heart beating at different caffeine concentrations. Note the caffeine concentrations down very, very carefully. They're not necessarily in the right order or in a sensible logical order. This one is 0.05% caffeine. You can count the heartbeats by dotting with a pencil onto a piece of paper, making your dots into a shape like an S so that you don't put one dot on top of another. Since you're looking at a film, another thing you can do is to slow the film down using Windows Media Player or some other media player in which you can have a slow motion facility, and that makes the heartbeats easier to count. You can even go frame by frame and get some very accurate results. Other methods include using a tally counter and using a button on a calculator. It's quite often worth doing this in pairs so that one person keeps an eye on the time and the other does the counting. And it's usually not really possible to count for more than about 15 or 20 seconds. So if you want to make your counts per minute, you'll need to multiply by 4 or 3 or whatever's appropriate. So now the caffeine concentration has gone down by a factor of 10. We're down to 0.005% caffeine solution. Do you think the heart looks as if it's beating any faster or slower or about the same? your count ought to tell you. Now we've dropped the caffeine solution another tenfold. We're down to 0.0005%. These concentrations have been chosen with some preliminary work, looking at where rather higher concentrations actually have an adverse effect on the Daphnia. Again, does it look any different? What do your counts tell you? And finally, we've got what you might think of as a control. If you just wanted to compare no caffeine with caffeine, this is the no caffeine Daphnia, 0.0% caffeine, in other words just plain filtered pond water. Not a good idea to put the Daphnia in tap water, not a good idea therefore to make the caffeine solutions up in tap water, and distilled water is probably better, but the best thing of all is the pond water in which the Daphnia were living, or the water in which they came from the pet shop.